Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends, in this example let's say we have made a solution or wrote the code by using if and while together in the previous video. Let's try to convert them directly to for. I took the same samples. Unlike the previous video, I will try to solve an extra example. Let's talk about how to convert this to for first. Again, in our first example here, our aim is the same as the previous video. We had an example of adding the numbers in the x that are divisible by 3 in the y arrays and get 3, 6, 9, 11, 15 for me. Now I can write this with for comfortably, even more easily as I wrote it with while. Let's write for here again. Here we can directly increase 1 by 1. Here we define an I number. Here I can define how far it will go and how many it will start. And while I was writing the starting point, and I was writing 2 lines extra because I wrote the increment process as I equals to y plus 1, for allows me to write shorter this way. Why did I write to 10 now? More preciously, since there are 9 numbers, I want him to count up to 9. That is how many cards in the x arrays should count as much so that I can check all of the x for me. Let me go over all the x's so I can go over them into turn like 3, 4, 6. So we will start adding to y as I have to split a condition to the whatever happens. Of course, since 3, 6, 9, 11, 15 here are numbers that can be divided by 3, I need to state division by 3 here again. So I say rem a b and look, it turns, that's help right here. Here x of I xi, which means xi will start from 1, so it will start with 3, continue with 4 and go up to 15 like this. Now I say take the term rem xi 3 I point of x and divide it by 3, you know, but again we use expression equals to question whether it's equal to in if. Now I say if the remainder of the division by 3 equals to 0, so I ask the remainder of the division by 3 if rem x I 3 equals 0. Later on, if this is divisible by 2, which is my aim to draw divisible by 3 to y, I say okay, I will write what y will be a little later. Let's even write down y will be. I have to define another variable called y. I cannot say ye to the number of elements of y here because the number of elements of y is not equal to I, so there will not be 9. Since there will be 4 or 5, I'm defining a new variable here which I will guarantee to go up to 5. That's why I call him j. Of course I have to define j outside first. Without its initial value, MATLAB cannot process. So the first value j starts with 1 here. Since j starts with 1, we will get whatever value it gets first, where it will take 3 and divide by 3 exactly. It doesn't really matter to us whether it is divided or not right now. I'm just trying to write the rule properly. If we write the rule properly, it will automatically draw the number that can be divided by 3 from here. And therefore, a yj from the xi si is which height, if we are dealing with the term, I will say equal to it. Of course, before I exit this if, I will increase j by 1 so that the second j, that means j equals to 1, turns out to be 2. So let's set it to be in the second term of y. In this way, our aim is make room for new employees. Then I close the if. So it stays if other conditions are not met, there is no need to write else. In all other conditions, it will pass without being divided into 3. In other words, this will not suffer the if. Of course, it will not be able to automatically hit the y in this part. So I can directly write the code that way. Of course, here I can now complete the for like this. Let's check if we have any shortcomings. If we are lacking, we will already get an error. I don't seem to see any error right now, but let's give it a try. Let's see at y, can we see that? I run the program. Of course, we will save it again before we run the program. Let's save it as lesson 11_1. And now let's see. Look, as you can see, our x values are 9 like this. This is how we obtained 5 values that can be divided by 3 from these 9 values. Again, there was another example we did with while. In integers up to 10, he was adding the odd numbers in y and the even numbers in z. So how do we do this with for and while? Let's think again if you want. In division divisibility rule, the best way to understand whether a number is odd or even is to divide that number by 2. There are 2 possibilities to stay with 2. Either divides perfectly and gives the remainder 0 or gives a fully divisible remainder 1. So there is no other possibility in the division by 2 rule. Since we are dealing with odd and even numbers here, we can easily apply this rule. Now I will start the for loop again. Since the number of elements of x is 10 from 1 to 10, I started from 1 and increment them 1 by 1, although I write I equals to 1, 10, I normally write it as 1 equals to 1, 1, 10, so that is sufficient but looks clear. Let's remember the for again. For I equals to 1, 1, 10, so go from 1 to 10, 1 by 1. For is written like this, and of course I have the question again. I say if. What are we going to say? Of course, I type the rem command for what? We will take the xi as inside 1 by 1. What I look for the section, here I say if the remainder of the division by 2 is equal to 1, if rem xi 2 equals 1. I mean, if it's not divided by 2 exactly, I will give the remainder, so I can sum the y's here. Now if the remainder is 1 with 2, let's do it like this. If you want, let's write full division first. If I do not remember correctly, is the previous question, I wrote the full division first. Let's try to compare it to the previous question. Let's divide it fully. If rem xi2 equals 0, it is divided by 2, these guys. So it is related to z. Then I will do the assignment of z's. Since the number of elements of z is not the same as I have to use another variable. That is why I say zj as I did in the previous example. So it's automatically equal this zj to xi. Whatever value of x comes from here, they will come from in order to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Whichever of them is divided by 2 and can enter this if. It is not a problem for us because we add the ones that divisible by 2 in z anyway. Here before leaving the if command to make room for new j's. So I'm going to increase the j to make room for the second, third, fourth, and fifth elements of the z so that an array starts to from. Normally I just have to end it like this because there is no other possibility. If it cannot be divided by 2, those who give the remainder of 1 remain, you can do the direct as follows. If you wish, let's do it here again in a way similar to the previous question. Let's say else if. And this time let's ask the incoming I of this rem xi could not be divided exactly by 2 above and could not give the remainder 0. So let's ask if this given a different remainder like 1, else if rem xi 2 equals 1, and I define a new variable for k. If it gives a remainder like this, I now equate the incoming xi to this yk equals the xi, and I now know that these xi are numbers that cannot be divided by 2. I automatically put it to yk. Of course, yk will also start at 1, and I have to increase them 1 by 1. That space is made from ys k equals to k plus 1. And of course, I have to define j and k here. Otherwise, if you want to start from, MATLAB cannot recognize it. Do you need anything else? Just write the end of if and at the top I wrote that. And I also have to write the end and for. We need for else if. I wrote this way. Let's see that y and z, if you wish. Can we see odd numbers in y and even numbers in z, we will take a look at now. Let's run our program. Let's save it as lesson 11.2 underscore 2. So we use underscore instead of point. Let's see if we wrote it right. Yes. Our x values here were again from 1 to 10. We see that our values for y are odd numbers and our values for z are even numbers. We have achieved this very well, guys. After doing this, I'm writing another example. Now this will be a different example. For example, in the previous while and if. Now I will do something like in this example. Again, let's write our classical command first. Again. Yes. Then we have an array like this. Look, my aim is this time I created an x array from 1 to 15 like this. X equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I'm writing my purpose. My goal is this. My aim is to have numbers in the y array that are divisible by 3, but these numbers should not be divided by 2. So what is y then, guys? It tells me that there are numbers in y array that are divisible by 3, but these numbers should not be divided by 2. What do you get from here? What do you get from here? This cannot be divided by 3, but not by 2. IA 6, which are there. If we go in turn, y may also be 3. Could it be 6? It can't be, because 6 can be divided by 2. Because 6 can be divided by 2. Yes, it can be divided by 3, but not because it can also be divided by 2, because I want it not divided by 2. It tells me get those that are not divided by 2. Then I will not take 6. I can get 9 because it's not divided by 2. Can I get 12? I can't take 12 because this is not a number that cannot be divided by 3 and divided by 2. 12 can be divided by 2. Who is left and cannot be divided into 15 remains. Divide by 3 and odd numbers that cannot be divided by 2 in y. This is my goal. How do we do that now, guys? Maybe it looks a little more difficult. But let's try and see how we write. Now I opened the for loop again. Again, as always, our classic process in this, guys. Here you will write the number of elements of what you will choose among. Now let's write a little more code, and I say this: start from 1, increase 1 by 1, go all the way to length x. So there is no difference between me writing length x, here I'm writing 15, which is the element number of x. I'm just writing with some more code. Let's do it like this for I equals to 1 length x. Let's do it. So what? Yes. So what I do here is no different. It says 15. There actually, because I know the length x is 15. So it says I equals 1, 15 there. Now we're determined. Then I will return it again. While doing this rotation, I have to ask if the y is divided by 3 and not by 2. So how do we do it? Of course, I have to use an if command, and I have to ask whether the remainder of incoming xi it was. So call the x in order from above. And what should we divide this xi into first? Once it has to be divided by first, what do the numbers I get in common? The common feature of these, their numbers 3, 9, 15 is that they can be divided into 3. Now if remainder from division with 3 is 0, so if you pass here, let's add u value of j and write j equals to j plus 1. Of course, it will start j at 1, and before this increment is done, we have a j. I equate the term to xi, yj equals to xi. I actually took a risk right now because I don't know 6 with this comment right now. I can't check the 6 here, so I haven't checked the division by 2 yet. Something like that came to mind here, that I would show it. Right after this, let's enter another if command xi if rem xi. Let's check 2 here. Let's ask again if rem xi 2 equals 4. Now a number divisible by 3 has entered here. If it doesn't, we will extract it directly from the code without going through both this if and this if. Let's say 6 entered here. 6 is divided by 3 exactly and gives a remainder of 0. Here then I synced immediately. Even though it seems like I have a mistake here, something came to my mind. In this value of 6x, I exactly divided by 2 dividing. This is divided here, guys. Then I say don't decrease j. So the j I increased over there. After all, it came here by entering 6 because it was divided by 3. We increment j by 1 here since it also stops here. For example, we made 2 while it was 1. Then I say decrease j again. Reduce the j again so I can overwrite the next 6 and there and destroy it. I close this if with AND. I close the next if with this AND. To turn off the 4 at this end, we will we will reconsider what I said, but first let's check if we wrote it correctly if you want. In other cases, if rem xi3 equals 0 is not divided by 3, this if closes right here. Since this if is closed here, it will automatically stop here or something. It won't automatically hit the y either. So a number that is not divided by 3 will not be here anyway. So let's see if what we think is true. After that I will tell you again what I did hit there. Let's see the y here. Let's see the y array. Let's call this lesson 11_3. Let's see what came up. As you can see, x was our array from 10 to 15. We got 3, 9, 15 correctly. So how did this happen? Let's evaluate it again. It was like this, guys. See, x entered as 1 here, entered as 2. It is obvious that these 1 and 2 are not divided by 3. When it is not fully divided, we do not enter into if because it does not provide the if part of the code here. Without entering here, we get the new value of I directly. The first 2 values are not split anyway. Let's continue by taking I as 3. Take this 3, which is the third value of x when I is 3. The remainder of division by 3 with 0. Now our j value is 1. And equate y, j or y1 to x3. What is x3? 3. We equalized it as follows. I will try to show it by writing if you want. Let's write j equals to 1. Let's write yj equals xi as follows. Let's write I equals to 3. There I wrote y1 for j equals 1. In y1 corresponds to x3 or 3. Now let's continue with the code. Here I synced it like this. I'm incrementing j by 1 and j is now 2. I typed j equals to 2 and continued. Then he immediately entered this if and checked it. If this xi means that value of 3 is divided by 2 exactly, it says decrease j by 1. So is 3 divided by 2? Since it is not divided, it does not stop here and decrease the j, guys. The j value is still true. I think there is no problem so far. Now we continue after that. Our I value of 4, 5, it will skip this place directly as it knows that it is not completely divided here. Again, the critical value for us was 6. Actual critical value 6, the point where we'll understand the logic of the reduction is 6 for us. We entered 6. Our j value is still 2 at the moment, we don't forget it. 6 entered. What is the remainder of 6 division by 3? It is 0. It is fully divided. What did we say that? Equate yj to xi. Let's get it equal. Since j equals to 2 and yj, we equated our value of y2 to 6, which is the 6th value of I. y2 equals x6 equals 6. But I don't want 6 in y because look, since 6 can be divided, there is no 6 here by 2. I want it not be divided by 2, so now 6 entered here. Now here our j value is also 3. Look, j entered as 3. Check in now. We control the remainder of 6 division by 2. I decrease the j by 1 again because it is divided completely. What was j just now? Guys, it had been 3. See, now I pull j back to 2. J is 2 again, and then I continue the code. 7 and 8 have no effect anyway. What will happen? We get to 9, guys. 9 is divided by 3 exactly. What is our j value now? What will it say here, because our j value is still 2 now? What should yj be equal to? Again, automatically y2. Let our next value y2 be equal to xi. So it will equal to 9. We came to term 9 because get equal to 9. y2 equals x9 equals 9 automatically, while MATLAB kept the previous y2 as 6. So while MATLAB kept in this my own information that we seem to have written in over afterwards, we said the new y2 should be 9. It was automatically written over the 6 here as the value 9. This is the logic of the event. Likewise, 12 will come. When we reduce j again, it will be like this. It will automatically be in from y3 equals to 12. But again, I will reduce the j because it's divided by 2 in that region. J will decrease to 3 again. And what about the new y3? This y guy, the newcomer y3 equals to 15. I hope I could explain what I mean. I think this is a good example to use if and for together. We solved 3 examples. I hope to meet you in another video. Goodbye.